This is your external investigation of the spiny dogfish. We are walking through your investigation guide, so step by step. This would be your external anatomy, so giving your external view of your spiny dogfish a quick look. Just rotate around. So external anatomy is photo number 1. That would be your first quick photo. Photo number 2 asks you to take a photo of your dorsal side of your shark. So dorsal would be where the dorsal fin is. This is your first dorsal fin, so this is your dorsal side. If you were looking at the dorsal side of the shark, sharks have what we call counter shading, so opposite shading on their body. This top dorsal side of the shark is going to be a darker color. If you were talking about ecology as the predator or the prey, sharks having a darker color. Predator on top looking downward would see more of a dark color against the sand. They're more camouflaged. If you were to flip your shark, as we said, counter means opposite. Their ventral side, so not dorsal but opposite, their ventral side is lighter colored. So if you're a fish or a predator swimming underneath the shark and you look up at the ocean, it's going to be more blended in with the sunlight coming through the photic zone, that upper lit part. So photo number 2 was take a dorsal side photograph, and I kind of just jumped around a little bit, but along with your dorsal side, all fish, like we spoke with your bony fish too, have what we call the lateral line. So if you're following this very distinct line down both sides of your dorsal side of your shark, this lateral line is what they use for mechanoreception. So that lateral line, again, is how they detect those vibrations in the water. So we want to make sure we can label that lateral line. We did counter shading and talked about the ventral side, but you do need to snap a photograph of the ventral side of your shark, which would be the bottom. So this would be your ventral side. You don't have to label it, just show me that. Placoid scales would be something that we would want to look at on this shark because they are chondrichthyans. So placoid scales, you can feel them on the sharks, especially with their skin being in one direction smooth and one direction rough. You have some scales on your investigation guide, but I'm also asking that you pet your shark. So this should be a cute moment with your lab. You're petting your shark from the snout to the tail, and you will feel some kind of texture. So when you feel from snout to tail, it will feel one type of way. When you pet in the opposite direction, so from the tail to the snout, you will feel a different type of texture. That's what we're doing. So very sensory, pet your shark, and then show me that if these were the placoid scales of the shark, when you pet it from the snout to the tail, they are laid in such a way that they are smooth. When you pet it in the opposite direction, you are petting against those scales. So petting against it, it feels rough. That's why they're able to swim so fast. So those placoid scales are what sharks have and what you can feel when you pet the shark. I do ask that in this lab we cut a couple of sections of skin off to make a microscope slide. So I'll explain to you how to do that, but we're saving that part for internal, so day 2. So right now just feel the shark skin before we make our slides. We're getting into the fin diversity, so that's the external, kind of look at the shark, feel the shark, touch the shark, those are the scales. When we start looking at fins, as we've learned with the fish, all fish, most fish have a dorsal fin. So this is your first dorsal fin of the spiny dogfish. It is then followed by the second dorsal. So first dorsal, second dorsal fin of our shark. Those are one photo, so one photo of your dorsal fins. Our pectoral fins are these on the side where your pecs would be. So these are the pectoral fins of the spiny dogfish. You're going to label 1 and take a photo. Those are the pectoral fins. Pelvic fins are located near the pelvis. They are a vertebrate, so they have a pelvis, and these are going to be your pectoral fins. No, I just lied to you. Those are pelvic, because we just did pectoral. So yeah, these are your pelvic fins. So please understand that this is the pelvic region of the shark. This is intestinal stuff that has come out, but these are going to be pelvic fins. And then when we get to the end, we have our caudal fin. Caudal fins of sharks are very unique, as you can see. We're looking at two different, what we call lobes of the caudal fin. We call this a heterocircle tail. So literally hetero meaning different, means that there are two different shapes or sizes to the caudal fin of the shark. This is the upper lobe and the lower lobe of the caudal fin. This is providing lift. So just like an airplane that has a fin to provide lift in the air, this part of the shark will help provide lift and buoyancy in the water. That's how they provide their own buoyancy, along with their insides, which we will speak about tomorrow. Those are the fins. And when we get into the sensory part of the shark and how they can sense you in the water, we spoke about the lateral line, so you've labeled that. That's mechanoreception. If you look at the snout, so we're gonna get a real close look at the snout. This is the snout region of the shark. So on this very top part of the snout, you wanna go angled up, because I'm about to squeeze it. When you look at, and can you come around from this angle, because I think we have better lighting. When you're looking at the snout, we have our upper region. We have all these tiny pores, so you really can't see it, but you kind of can. All of these pores are filled with a jelly-like substance. All those pores are called ampullae. So this entire structure that sharks can detect you with electrically, we call the ampullae of Lorenzini. And when you have your shark, you're expected to squeeze the snout. And most of your sharks will have, that was gross, a type of jelly that comes out. Some of them, because they're in a preservative, it will not be as thick as you would imagine, but this jelly is what they are basically detecting your heartbeat with. It travels through the jelly and into their sensory organs in their head region of their brain. That is the sensory part of the shark. So when you get to the snout, that's what we're labeling. This is the snout, and any of the holes that you wanted to look at are the ampullae of Lorenzini. We also have it on the flip side of the shark. So if you were to look at the very small holes up here near the nares, so these are the nostrils, this would be more ampullae. So they're really good at detecting you, whether it be the vibrations because you're swimming around, or electrically your heartbeat through their ampullae. That's the snout. That's called electroreception. When we look at the head region, we have the eye. So this is your eye. We have what we call the spiracle, and the spiracle is literally this opening behind the eye. So when you look at the spiracle, you're looking at this opening. It's essentially the primitive way that ground sharks, so what we call carpet sharks, the very primitive types of sharks, chilling on the bottom of the ocean, you don't want to open your mouth and take sand in. So when you're trying to get oxygen across your gills, you open your mouth. That's what sharks do to get that oxygen across their gills. So when they have carpet shark lifestyle, I don't want to eat a bunch of sand, this spiracle was used to help move water in through their body across these gills without having to open their mouth. So the spiracle's function is to allow water to flow through the body over the gills and then back out. The gill slits are what we saw here. So these gill slits are literally what they are. Slits that the gills would be underneath. So this shark specifically, you're gonna count how many gill slits we have. And these gills underneath, you'll be able to see when we do our internal. And I already jumped ahead, but we did mouth underneath. So they are not like the great white. They don't have enormous teeth, but they do have rows of teeth. That's the mouth. We looked at the nares, so the nostrils. Those are the literal holes in which they smell things. So the nares. And then the ampullae, so we've looked at our ampullae of Lorenzini, those jelly-filled pores. The reproductive anatomy is different. This is a female. All of your sharks will be female because they're all pregnant, so you'll be able to be a whole shark parent tomorrow. This is intestinal, like I said, so this is not something that you should look at today, but if we were to look at this part of the shark, the opening in which most and all things happen for sharks is called the cloaca. So male and female sharks have a cloaca. That is the opening, again, waist removed. These are females, so they have two fins and a cloaca. If we were looking at a male, they would have two reproductive structures called claspers, which I don't have any males to show you, but essentially a male shark will take his claspers and clasp onto the female. So when you recognize the sex of a shark, this would be a female because there are no claspers. and I'll show you a picture of it, but the male would have those 2 additional structures that he would use during reproduction. And that is the external anatomy of the spiny dogfish. The only other things that I may have forgotten are these species are specific with their coloration, so you'll see these spots. All the spots on the spiny dogfish are a type of coloration we call disruptive. So by providing something that a predator is confused by, you are then camouflaged, and especially in the open ocean, this coloration of being gray colored or even silver like some of the fish are, very advantageous for them. This is called the spiny dogfish because they have one spine that would be in front of the dorsal fin. However, these spines have been cut off during packaging. So that's a unique feature. It is a fish, it has a spine, spiny dogfish, boom.